On the board we have the graph of the sine and cosine functions. Let's talk about their graphs a little bit. For the graph of sine of x, notice that if I were to grab my graph and rotate 180 degrees, then I'd get an exact copy of what I started with. Graphs that satisfy this property are said to be symmetric about the origin. For functions whose graph is symmetric about the origin, they are said to be odd. So sine x is an odd function. What about the cosine of x? Well, cosine x, notice the left side of this graph, left of the y-axis, is a mirror image of the picture on the right side of the graph. So we say the graph is symmetric about the y-axis. Right? If I were to flip it about the y-axis, I'd get exactly what I started with. For functions that have this property, we say they are even. So cosine x is an even function. So what does this mean a little more technically? Well, let's pick some, let's just say negative 3 pi over 4. Right? Negative 3 pi over 4 has a function value down here of negative 1 over radical 2. Right? If I were to look at positive 3 pi over 4, right, then this negative 1 over radical 2 has become a positive 1 over radical 2. So the technical way of expressing that a function is odd is to say, well, let's keep it in terms of sine. Sine of negative x is negative sine of x. What about for even functions? Right. Well, again, let's look at negative 3 pi over 4. Right? Negative 3 pi over 4 for cosine x is going to have a function value down at negative 1 over radical 2. But if I look at positive 3 pi over 4, the function value is still negative 1 over radical 2. So the technical way of expressing this, cosine of negative x is equal to cosine of x. Okay. Let's work through some examples to make this a little more concrete. Sine of negative 2 pi over 3. Sine is an odd function, so sine of a negative argument is negative sine of the positive. So negative sine of 2 pi over 3. Sine of 2 pi over 3 is negative root 3 over 2. I'm sorry. Positive root 3 over 2. And so for a final answer, we get negative root 3 over 2, which is something that we could have handled directly just by looking at the unit circle. Right? But what about angles that we are far less familiar with, like let's say negative 10.1 radians, right? Well, this is equal to the negative of the sine of 10.1 radians, whatever that happens to be. Cosine, let's look at cosine of negative pi over 4. Cosine is an even function, so my function value to the left of the y-axis is going to be the same as my function value to the right of the y-axis. And this, of course, is 1 over radical 2. Again, this is something that we could have handled directly by looking at the unit circle. So let's take a look at something like cosine of negative 5 radians. So cosine of negative 5 is going to be equal to the cosine of positive 5 radians, whatever that happens to be.